This is section 9.1, where we are adding and subtracting polynomials. There is a lot of new vocab for this section, but we're going to be using this throughout all of chapter 9. So first we have a monomial, which is a number variable or product of a number and one or more variables with whole number exponents. So that just means no negative exponents. A lot of what we did in chapter 8, those were examples of monomials. The degree of a monomial is the sum of the exponents of the variables in the monomial. So 5x to the fourth y squared, for example, has a degree of 6. A polynomial is a monomial or the sum or difference of two or more monomials, and each of the monomials is called a term of the polynomial. So, kind of breaking down the word, poly for polynomial just means multiple or more than one, and monomial just means one. So basically you can think of it as a monomial is just one. So like down here the 2x cubed by itself would be a monomial, but the 2x cubed plus x squared minus 5x plus 12 becomes a polynomial. Some other common words you'll hear, a binomial is just a polynomial in simplified form with only two terms. And again, kind of breaking down the word, the 2 tells us the binomial. So then it makes sense that a trinomial has 3 terms. And the degree of a polynomial is the greatest degree of any of its terms. So for example, 4m cubed plus m squared minus 5m has a degree of 3. And notice that it's in order, it's kind of decreasing. The monomial with the largest degree comes first, and the one with the smallest degree comes last. So the leading coefficient is the coefficient of the term with the greatest degree. For example, 4m cubed plus m squared minus 5m, the leading coefficient is 4. So remember, 4 and negative 5 are both coefficients because they're next to the variable. And m squared would have a coefficient of 1, but that first number is the leading coefficient. And in this last example I have down here, 2x cubed plus x squared minus 5x plus 12. 12 does not have a variable next to it, and remember we call that a constant term. Our key concepts: a polynomial is simplified when there are no like terms present, so you've combined all the like terms. It must be simplified before you try to identify the degree. A simplified form should always be written in order of decreasing degree of its terms, so that's sort of why in number 2 it has to be simplified first. And when a polynomial has more than one variable, it should be written in decreasing degree and alphabetic order. So for example, 2x squared plus 3xy squared plus y cubed. Well, sometimes you'll ask, well, why is the y cubed last? And that's because you have to do alphabetical order and then order of degrees. So xy is technically a term that would come before y because it has an x in it. Okay, so in adding and subtracting polynomials, there's two methods we can use. There's the horizontal method and then the vertical method. So let's look at horizontal method first. If we are adding the polynomial 3x squared plus x minus 6 plus the polynomial x squared plus 4x plus 10, what we have to do is get all the like terms together. So one way to think about it is that since addition is commutative, we can just rearrange everything and get it together. So one thing you need to remember is if it says minus 6, we can think about that as adding a negative 6. So here they've just put 3x squared plus x squared, x plus 4x, and then negative 6 plus 10 to get all the terms together. So then that's 4x squared plus 5x, and then negative 6 plus 10 is 4. So don't forget, if there's no coefficient listed, that means it has a coefficient of 1. So if we try another example, sometimes I find colors can be helpful. But if we look at number 1, 4x squared plus 2x minus 6, that's fine. But then 3x squared minus 2x cubed plus x minus 3 technically isn't all the way simplified. We should have negative 2x cubed plus 3x squared plus x minus 3 in decreasing order. So the x cubed needs to come first. So I'm just going to rewrite that first. And then let's think about what goes together. So 4x squared and 3x squared, 2x and 1x, negative 6 and negative 3, and then the negative 2x cubed is by itself. So if I rewrite this, putting them together, I have negative 2x cubed plus 4x squared plus 3x squared plus 2x plus x plus negative 6 plus negative 3. And then for my final line, I have negative 2x cubed, 4x squared and 3x squared is 7x squared. 2x and 1x is 3x, and negative 6 minus 3 is minus 9. And that would be totally simplified for that example. Okay, for the horizontal method, we can also do subtraction. So what's easiest for this is to think about that subtraction as like multiplying by a negative 1. So before you do anything, you can just distribute the negative 1 to everything inside the parentheses, and then it just becomes adding like it was before. So here they distributed, they got negative 3x squared, negative times a negative x became plus x, and negative 1 times negative 8 became plus 8. And then again, just grouped the common terms together and simplified. So if we try the next one, first thing again, notice they're not all the way simplified because they're not in order from greatest to least. So first we need to reorder, so we end up with 6x cubed plus 2x squared minus 4x plus 3 minus 3x cubed plus 5x squared minus 2x plus 1. And here I need to just distribute that minus or that negative 1. So I end up with 6x cubed plus 2x squared minus 4x plus 3 minus 3x cubed minus 5x squared plus 2x minus 1. And again, I can just group everything together. 6x cubed, negative 3x cubed, 2x squared and negative 5x squared, negative 4x and positive 2x, and then 3 and negative 1. So 6x cubed and negative 3x cubed becomes positive 3x cubed. 2x squared and negative 5x squared becomes negative 3x squared. Negative 4x and positive 2x becomes negative 2x. And then positive 3 and negative 1 becomes plus 2. So that would be our final answer. Alright, the vertical method is very similar. We're just going to line everything up instead of writing it from left to right. So I have 9y cubed. I have positive 6y and negative 7. Notice I left a space because this one doesn't have a squared term. And then if I'm adding that to the second one, I have a negative 3y cubed. I have a negative 2y squared, positive 4y, and positive 5. So now I add straight down. 9y cubed and negative 3y cubed is a positive 6y cubed. Nothing to combine there, so I'm just left with negative 2y squared. 6y and 4y is 10y. And negative 7 and positive 5 is negative 2 or minus 2. So notice for that one, the only place that you have to be very careful is to make sure that if they don't have the same number of terms, notice this one has 3, this one has 4, you need to make sure you leave a space so you're not adding the 6y to the 2y squared. Right? We can only combine them if they're like terms, and they're only like terms if they have the exact same variable raised to the same power. The vertical method for subtraction is very similar again, but you're going to distribute the -1 so that you're then just adding. So for this example, notice again this one only has 2 and this one has 3, so we're going to have to be careful. The first one, 5m squared, I don't have an m term, and then I have a -6, and then I'm subtracting a -1, so I'm going to write adding -3m. Negative times a -2m squared becomes +2m squared, and then negative times a -1 becomes +1. And now I just add 5m squared and 2m squared is 7m squared minus 3m, -6 plus 1 is -5. And that's it for this section.